Well, guys, you've done it. You've knocked out one chapter of accelerated geometry. So give yourself a big hand clap of praise, a pat on the back, a punch in the face, whatever you do to celebrate. And another reason to celebrate is we made it to a Friday. We've got football tonight. I'm excited to see us take care of business on our first home game. And I'm also excited for us to take care of business on the first day of Chapter 2. Now, even though our tests this year are not going to be the same as what you see here from previous years, multiple choice, short answer, free response, all of the same concepts are still there. In fact, think about it. Remember day one from last chapter? Conditional statements. If then. Conclusion. Conditional statement. How about this? Complementary or supplementary angles. We saw that back on day 7. Finding the possible correct range for an angle. So finding angles. And you see more of that down here. We have angles. We have, some probability. Throw back to day 9 and day 10. So how about this one? Mutually exclusive events using the word or. We had a problem on our test about that. Finding the probability when we're good with one thing or the other. And then finally, being able to solve multi-step equations based off how angles are related to each other. Now, some of the things you're not going to recognize are proofs. That's going to be a new one. And I'm not going to lie to you guys. In my opinion, Chapter 2 is going to be the toughest chapter. Now, here's the thing. For some people, I'm not going to say for everybody, this chapter has a lot to do with proofs. And there are some people who are absolute gods at proofs. And I'm hoping you're going to be one of them. In fact, I'm hoping by the end of this chapter, you all are going to feel good about proofs. So let's get into it a little bit. Let's jump into day 1. We see that our topic is going to be the same as it was sort of back on day 1 of chapter 1, conditional statements. And I'm going to give you guys a second, but this is all, in this box, this is all a day 1, chapter 1 recap. But please, let's take some time and let's read this. Okay. When it comes to conditional statements, we know there is an if-then relationship, where if is the hypothesis, then is the conclusion. If is the hypothesis, then is the conclusion. And a lot of times we're going to use the phrase throughout this chapter with P and Q. We say P leads to Q, or if P, then Q. Sometimes we'll say P implies Q, but this is going to be the main one right here. If P, then Q. If your hypothesis, then your conclusion. Speaking of which, we know our hypothesis has to do with the if part, and our conclusion has to do with the then part. And if you remember for the very end of day 1, we talked about how the converse is just when you switch the hypothesis and the conclusion. So that's when you flip them around to get the converse. So I'm going to see what you guys remember here. Let me give you guys a second. I want you to try numbers 1 through 3. Take some time. Try 1 through 3 for me. All right. Let's see if you guys went 3 for 3 on this little recap from a chapter ago. An animal is a bird is our hypothesis. The animal is a robin is our conclusion. And first off, is this true? If an animal is a bird, then the animal is a robin? No. That's actually false. So again, remember, sometimes conditional statements won't be true. But is the converse true? If the animal is a robin, then that animal is a bird. That is true. So how about that? And that's actually what question 4 asks us. If the converse is the converse true or false? True. Because, well, all robins, I don't know what's going on with my writing today, all robins are birds. It's as simple as that. I'm going to let you guys practice writing the conditional statement for this right here. So go ahead, try number 5 for me. So, if an animal is a dolphin, then that animal is a mammal. And that is a true statement. All dolphins are mammals. So how about that? Now, here's what we're going to consider some different ways we can kind of mess with the conditional statement. There's different ways to represent it that can change what it says and what it means. So we already know about switching the hypothesis and switching the conclusion. We call that the converse. We've already talked about that one. Here's one we haven't talked about, negating. So you can negate. So the negation of a statement, so in other words, negating the hypothesis, is the opposite of the statement. Look at that great highlighting job. It's almost what got me held back in kindergarten. Let's maybe take a look at this here in a second. But first, let's kind of look at our initial statement. If the measure of an angle, A, is 15 degrees, then that angle is acute. Well, that is true. Acute angles are any angles under 90 degrees. How about the converse? So we flip the hypothesis and conclusion. If angle A is acute, then angle A is 15 degrees. That is false. There are plenty of acute angles that are not 15 degrees. So that is 100% false. Here's a new one. How about the inverse? When you find the inverse of a statement, that means to negate both the hypothesis and the conclusion of that original statement. So negating means to add the word not or no. So when we talk about negating, we're talking about adding that word not or no. And in this case, it means to negate both the hypothesis and the conclusion. So if the measure of angle A, we're going back to the original, does not equal 15, then the measure of angle A is not acute. So if angle A is not 15 degrees, then angle A is not acute. Well, that's also false. There could be plenty of measures that angle A could be. It could be 16 degrees or 17 degrees that would make it acute. So that's false. How about last one here? Contrapositive. So write the contrapositive of the statement, which means we're going to negate both the hypothesis and the conclusion of the converse. So this one's really weird. So negate both the hypothesis and the conclusion of the converse. We won't see this one a ton, but it's actually the logical equivalent of the original conditional statement. So in other words, the contrapositive is really saying the exact same thing that the original was. They're connected. So see if this rings a bell. If the measure of angle A is not acute, so in other words, the converse where we flipped it, but now we're negating the converse. So we flip and negate. This is like a combination of inverse and converse. It's like putting these two together. If this angle is not acute, then angle A is not 15 degrees. So we flip and we negate. And this is true. All right, so I'm going to give you guys a chance to practice. We have a statement here. We're going to do the inverse, the contrapositive, and also let me throw in down here, we're going to do the converse as well. So take some time, see if you can get some practice in. And then, guys, after you've found these three, put a T beside it if it's true or an F beside it if it is false. So you can go ahead. Okay, so before we take a look and see about the truth or the falseness of these statements, let's look at the original. If the figure is a square, then the figure is a quadrilateral. Well, that is straight up true. All squares are quadrilaterals. How about the inverse? That means we now put not into both the hypothesis and the conclusion of the conditional statement. If the figure is not a square, then the figure is not a quadrilateral. Well, there are plenty of other figures that aren't squares that are quadrilaterals: rhombuses, parallelograms, rectangles. So this right here is false. How about this one? If the figure is not a quadrilateral, then the figure is not a square. Oh, that's the logical equivalent. Yeah, if a figure is not a quad, then it's definitely not going to be a square. That's true. And then how about if the figure is a quadrilateral, then the figure is a square? Well, there are plenty of quadrilaterals that aren't squares. So that's going to be false. Now, we're going to end today kind of talking about something called a biconditional statement. So this is going to be a little bit different from what we've talked about, but sort of in the same concept. So a biconditional statement is a single true statement. It has a true conditional and a true converse. So in other words, no matter which way you write it, if you flip the hypothesis and conclusion, it will still work. Now, you can write a biconditional by joining the two parts of a conditional with the phrase, this is a big phrase we're going to use a lot this chapter, if and only if, which we sometimes abbreviate as if. You can see this in action right here, if and only if. Okay, and so to kind of see what we're looking at here, we said we have a point as a midpoint if and only if it divides a segment into two congruent segments. So to make sure we do have a true biconditional statement here, let's see if we know that this statement is true. We did plenty of that back in chapter 1. Let's see if the converse is also going to be true. So if the sum of the measures of two angles is 180, then the two angles are sup. Well, that is, let's see about these right here. If the sum of the measure of two angles is 180, then the two angles are supplementary. We'll flip it. If, and we're going to abbreviate this, so be ready for some abbreviations. If two angles are sup, then their sum is 180 degrees. If two angles are supplementary, then their sum is 180 degrees. Oh, well, that's true. Well then, if that converse is true, let's rewrite it as a biconditional statement. So here comes our biconditional. And again, this is just where we involve our converse and the words if and only if. So, two angles are sup IFF, if and only if the sum of the measures of the angles is 180. So there is our biconditional. Two angles are supplementary if and only if the sum of the measures of the angles is 180. I'm going to let you guys try number 2 for me, and then we'll be about ready to wrap up. So if you were to flip the if and the then, the hype and the conclusion around, converse is true. So here is our biconditional statement. Angles are congruent if and only if the two angles have equal measure. And so we will finish up with this. Is this definition of a quadrilateral reversible? A quadrilateral is a polygon with four sides. Or what if we flip this? We said a polygon with four sides is a quadrilateral. Well, polygon with four sides is a quadrilateral. Yeah, it is reversible, which means we can do a biconditional statement. So a figure is a quad if and only if it is a polygon with four sides. And there you go, guys. Great start to the chapter. Not a single algebra problem or problem you had to work out to find a variable. Just some good old-fashioned logic. And so if you have any questions, let me know. We'll have a multiple choice on this day that I think will be great practice for you guys. So make sure we knock that out. Thanks.